Foxtrot has been neutralized. Hostile, light armor.
Spotted.
I have eyes on heavy armor west of your location. We neutralized objective Alpha.
All right, Ryan. It's been about 3 years since you've been on the show. I want to do another. All right, Ryan. It's been about 3 years since you've been on the show. I want to do another EDC. I'm sure you got a lot of new stuff you're carrying, but I know you want to break into a van right now, so let's go out. We'll start it out there.
Sounds good.
Cool.
Basically, what this attack is so there's an old school attack called a roll jam attack, which means that
We're going to hack the fucking van.
that's exactly right. But the roll jam attack means that you have to put a jammer somewhere near the car, and that stops the key fob from wherever you're at trying to unlock the car or lock the car. And then somebody is, not the jammer. Let's just say the jammer is right here, and then I'm standing, behind where the camera is right now, and I'm trying to receive that signal. That signal never hit the car because the jammer stopped the car from receiving it. In that case, the car recognizes that code as a legitimate code because the car has never said it's a used code. Does that make any sense, son? I'm trying to find a way to explain the roll jam attack.
So you jam it, and then you send a new code because it hasn't seen the new code before it works.
So a roll jam attack is you would put a jammer in front of it, and then you're clicking your key fob over there. Your key fob is not working because the jammer's stopping the car from receiving your unlock. And then I'm somewhere else over near you. I'm receiving you clicking the button, and then the car itself never saw that code, but I have it. So I have one shot because the car sees it as a valid code but never got it. So that's the old school way of doing this. What this method is when you click any button, whether it be the trunk, the lock, the unlock, the auto, it doesn't matter, any button that you click on your key fob, now I'm completely duplicating your key fob. So I have access to every single functionality of the car, whether it be lock, unlock, auto start, whatever it may be. And that is syncing with the rolling code system. It's not just that, it's not using the old school method. This is something that is being sold on the dark web for $500 to criminals. And Christmas is coming up. They're going to be going around popping trunks and standing in parking lots, just capturing keys, which I'll show how it works.
That's how I get my Christmas presents.
I know. I'm exposing how you do it. All right, so basically, now I'm just reading. And you already clicked it, but if you want to show the camera, every time he clicks it, you can see here, forward, forward, forward again. And it doesn't matter what button he clicks. It's just popping up as forward, right? So what I'll do is I'll click any of these, doesn't matter. And then I can save it. So I'm going to save it as 22. That way it's, save it as 22 just so that it's at the top of the list when I go to search for it. Okay, so now that I have 22, I'm going to hit emulate. And if you see on the screen, every single time I press a button, unlock, and then ready, I'm gonna lock. And you see how the code changed on the screen? So every time I click a button, it goes in line with the next rolling code in sequence that the key fob would have had synced with the car originally. So the danger in this is that by somebody clicking a button one time on their key fob, doesn't matter which one, now you have their entire key fob saved. And no, the flipper can't just do this out of the box. I don't think you're going to buy one of these and get into anyone's car. Like I said, it's being sold on a Russian dark web, wherever. I don't want to give the location, for $500 for any criminal to load onto their flipper, and now they can break into, sit in a parking lot and break into a bunch of cars in the middle, like during Christmas, and ruin people's holidays. So figured I'd get it out there so people are aware of it. And the solution to it is, sadly, go up to your door and physically use your key. Or if you're one of those people that have have one of those key fobs that you can get close to the door and click the button and it unlocks, that's okay as well. But if you click a button, any button on your key fob, you're at risk of somebody completely stealing your key fob and having forever access to your car. I have a list, there's a ton of different makes and models, but if you want me to just go over the brands, it would be Ford, Chevy, Kia, Hyundai, Subaru, Fiat. There's, let me pull the
Toyota?
list. Not Toyota.
That's good.
Let's see.
Honda?
Nope. Honda's in development, it says actually on the page. These are the vulnerable cars. And if I look at Ford, I see that
It's all of them.
the Transit right here, it is vulnerable. but it's models up to 2018, possibly up to 2022, but all the Fords.
Literally every.
Oh, so Mitsubishi, Honda's coming soon, Ford, Fiat, Chrysler, Dodge, Ram, Jeep, Ferrari, Maserati, Subaru, Hyundai, Kia, and basically every model within each one up to certain years. So a lot of cars, millions and millions of cars are vulnerable to this
I got a
attack.
question.
Yeah.
So some cars, if you don't have the key in there, then it's not going anywhere, even if it's started.
Yep.
So would the flipper act as the key? Would it
no.
trick the vehicle into thinking that it was?
You
the
can't
key so
drive
that you
away
could
with
drive
it.
away?
Not in this case. There are other ways to do that, but not with the flipper,
Okay.
and not with this firmware.
All right. Right on. So there is something the flipper can't do. That's good to know.
For now.
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44, a complete AI creation platform. Describe what you want, and watch it take shape. You can plan, customize, and expand.
Today we will try to build a super small but powerful air conditioning unit powered by solar panels. The idea is pretty simple. We will construct a small tunnel using these heat sinks. Inside of that tunnel the air will be super cold. It will be pushed out using this small turbofan, and the heat from the other side will be taken using these radiators. Additionally, we can use this to cool the hot water. And as you can see, in total we'll be using 6 Peltier coolers. I have no idea how powerful that will be, and the idea of today's video is to find that out. First, let's connect these two radiators so they become just one. We will do that using this metal wire. A small piece will just go inside. Once it is done, we can attach the second unit. Since we'll have some pressure from here and from here, I will insert this piece in between so it doesn't bend. The white modules will go to this side and to this side, so this gap can be covered with tape. Also, this side will be covered with tape so that no air will escape from here. Then we'll be using this flat piece of wood to build everything on top. We can measure where the thermoelectric coolers will go, and like this we get an idea where the holes needs to be drilled. And 6 holes later we can insert these metal rods. When this is done, we can start building the unit. First we'll put this water radiator, then we will add some normal thermal paste and install this unit on the top of this radiator. We repeat the process for the other units as well. And then we put more thermal paste to install the other heatsink. Let's attach the motor before we install this heatsink. This should work, and we can cover these small holes with tape again. This should be fine, and we can continue installing more units on the top. Hopefully I will not run out of thermal paste. Lastly, we install the other water radiator on top. And of course we press super hard, so the thermal paste fills in all the small gaps. Then I've cut some bicycle camera, so that we'll have something soft in between the two metals. And this piece will be pressing from the top. We install a washer just in case. And then we can install the last 6 nuts. Well, and this is what we get. Once we finish the unit, let's now sort out all the cables well. I will use these 3D printed pieces. And this is how it looks when all cables are organized. The 12 volts will be connected here, and the pump for water will also go here. Now this part is done and we can start building the water line. We will have to attach this somewhere, and then the 2 radiators will be connected with this pipe. This will be cooling the water, so now let's connect it to these radiators. So we will have this pump pumping the water from the bottle. It will enter from here and enter the top radiator. Then it will go down using this tube. Hopefully we have enough space there. Then it will exit using this tube and enter the radiator, and leave with this pipe back to the water bottle. For now we will use this as our water bottle. The pump will go right there, and the other end will go there as well. And now we can simply power it up. Cool, and with this looks like our water line is working just fine. So with this looks like our contraption is ready for the first test. We will power it with PC power supply unit rated at 700 watts. And we will measure the temperature with this thermal camera. Now everything is connected and let's power it up. Oh wow, and it seems to work. Well, basically these wires are getting super hot because of the huge current this machine is consuming, and then the air which is going out of the air conditioning unit is around 13 degrees. The water is 35. I guess this radiator doesn't help much. I mean, it is doing something, but it's super small, so it doesn't help much, of course. Then we have some water condensing here because the radiator is quite cold. Holy sheesh, the power supply is 100 degrees. Oh boy. Wait, let me clean everything up, and then we'll connect two power supplies and see what happens. Great, so now the working space is cleaner. I've also attached this duct in the end, and the pipes are attached here as well. We have two power supplies from a PC. One is 750, another one is 620, I think. So in total we have like 1300 watts of power for this air conditioning. By the way, if you're asking why I'm not using these ones to measure the power output, that's because these ones are only 10 amps max. And here we have like 20 or even 30 amps. Now everything looks literally the same because it's more or less the same temperature. Guess the water is around 30 degrees and everything else is around 30 degrees as well. Well, let's see what happens. Both are working. Nice, the cables are not that hot. The inside temperature is around 20 degrees now, and the water is heating up like crazy. I can feel the air is quite freezing. It is around 15 degrees now. The power supply is 40 more or less. Nice, and now we are down to 12 degrees. Pretty chilling. This one is warm, so I'm guessing the minimum we can get is 13. The water continues to heat up. I think if I stand in front of it, I will feel cold in like 5 minutes. Cool, so two power supplies work well. The maximum is 44, the water is getting to 35, and inside we still get 13 degrees. I'm pretty sure that the air that is coming from air conditioning is more or less 13 degrees as well.
4.
Well, anyways,
Short
that's it for
answer,
this video.
your
In
meter
the next
isn't
one, we will
actually
install it
measuring
in my
real
room
power.
and see how
It's
cold
picking
will
up
it
stray
get.
voltage because
Also,
the
I'm
inputs
thinking
are
on
floating.
adding more Peltier cooler
Here's
units,
what's going on,
so the whole contraption
step
will
by
become
step.
cooler. By the
Why
way,
a
look at all these
multimeter
droplets
shows a
of
reading
water
when
which are
nothing is
condensing on
connected.
this heatsink. Anyways,
One
I'm super
floating
curious
inputs
what you
plus
think
high
about
imp
this,
amps.
and I will see you in
Digital
the next one.
multimeters have very high input imp
In
amps,
today's video,
often
we're going
10
to build a
mega.
homemade air conditioner
When the
using
probes
very
are
few
not
components.
connected to anything.
Stay until the end.
Anything, they act like antennas. That lets them pick up ambient electric fields, nearby wiring, especially AC lines in walls, your body capacitance, radio frequency noise. This commonly shows up as 0.1 to 3 V, sometimes more. Your 3.0 V reading is classic ghost voltage. 2. You're in a voltage mode. Your dial is set to a voltage range, not resistance or continuity. In voltage mode, the meter does not inject current. It simply senses potential difference. With nothing connected, it senses noise. That noise gets digitized and displayed. 3. Non-contact voltage circuitry adds sensitivity. This meter has NCV, non-contact voltage, capability. Even when NCV isn't actively selected, the You can't completely stop a digital multimeter from doing this, but you can clean it up and control it so it only shows real voltage when you want it to. Below are practical, no-nonsense fixes, starting with the easiest. 1. Short the probes when not measuring. Fastest habit change. Touch red and black probes together. Or clip them together with an alligator clip. This gives the meter a reference and kills the floating antenna effect. Result, 0.00 V. 2. Switch to omega or continuity when idle. When you're not actively measuring voltage, set the dial to omega, resistance, or continuity, beep. Those modes inject a small current and ignore ambient electric fields. Voltage mode is the only mode that ghosts. 3. Add a bleeder resistor, best permanent fix. This is what pros do. What you need: 1 resistor, 100 k omega to 1 m omega, 1/4 W is fine. How to use it? Clip or solder the resistor between the probe tips. Or install it inside the probe leads if you're handy. This gives stray voltage somewhere to go without affecting real measurements much. Effect: phantom voltages collapse to 0. Real voltages still read correctly. 100 k omega equals aggressive cleanup. 1 m omega equals lighter cleanup. 4. Use low Z mode, if your meter has it. Some meters have low Z, low impedance, voltage mode. Your Mastercraft model likely does not, but check the dial or manual. Low Z loads the circuit slightly to kill ghost voltage automatically. 5. Don't hold bare probe metal. Your body capacitively couples to AC fields. Hold probes by the insulated handles only. Don't touch the tips while measuring. This alone can change readings by volts. 6. Reduce environmental noise, optional. If you're bench testing, move away from extension cords. Unplug nearby chargers. Turn off inverters or power bars. Keep probe leads short and twisted together. This lowers pickup. What not to do: don't assume any small voltage reading is real. Don't rely on voltage mode with open probes. Don't zero the meter by You're seeing exactly what happens when damaged probe leads are twisted together. Nothing is wrong with the meter. The probes are the problem. Why the voltage got higher when you wrap them together? Look closely at your photo. The probe ends are frayed copper, not solid tips. When you twist them together, the strands are not making a clean, low resistance short. Some strands touch, some don't. Oxidation plus tiny gaps equals rectifier/antenna effect. The meter now sees unstable capacitance, not a dead short. That's why you're getting 5.86 V instead of 0. It's still phantom voltage, just amplified by bad contact. Negative sign equals reference flipped, not real polarity. Yes, you should fix this. Do not keep using bare twisted strands. You have 2 correct options. Anything else will keep giving garbage readings. Option 1, best replace the probe tips. This is the proper fix. What you need: screw on or solder on multimeter probe tips. Or a full replacement probe set, they're cheap. Why? Proper You're not wrong. They're cheap because they're cheaply made. That's exactly the issue you're running into, and you're seeing the failure mode firsthand. Let's cut through it plainly. What cheap probes actually means in practice. On low-cost multimeter leads, manufacturers cut corners on all of this. Ultra-thin copper strands break easily. No proper strain relief, leads snap at the ends. Poor plating oxidizes fast rightward arrow unstable contact. Soft insulation cracks, pulls back, exposes copper. Bare wire ends instead of solid probe pins. So when the tip falls off, what's left is basically an antenna, not a measurement tool. Your meter itself is doing what it's supposed to do. The probes are lying to it. Why twisting or soldering the two leads together doesn't behave. A proper short is low resistance, solid metal to metal contact, mechanically stable. Your frayed ends are high resistance in spots, capacitive in others, acting like a tiny diode / rectifier, picking up ambient M noise. That's why you saw 5.86 V instead of 0. That's not power. That's garbage being amplified by bad probes. The lowest cost way to make them reliable, no bullshit. You do not need fancy probes. You just need solid metal at the tip. Option A, solder on solid pins, best cheap fix. Cost, almost nothing. Use any of these. Paper clip, steel, solid. Small nail. Sewing needle. Cut piece of solid copper wire, 14 to 18 AWG. How? Cut back to clean, shiny copper. Twist strands tight. Tin the wire. Tin the pin. Solder wire to pin. Heat shrink over the joint. Result. Stable readings. No phantom voltage when shorted. Stronger than the original tip. Option B, banana plugs, still cheap, much better. If your meter uses standard jacks. Solder on banana plugs are dirt cheap. Much stronger than molded probes. Lets you use clip leads later. This is how older, tougher meters were set up. What not to waste time on. Crossmark twisting bare ends. Crossmark taping frayed copper. Crossmark zeroing the meter. Crossmark assuming the meter is bad. None of those fix physics. Reality check, straight talk. Cheap meters aren't useless. Cheap probes are. Even a $300 meter will lie if the probes are garbage. A $20 meter with solid probe tips will outperform a $200 meter with broken leads. Bottom line. You're correct, they're cheap because they're cheaply made. Your readings are unstable because the probe ends are shot. Soldering on solid metal tips will immediately fix this. No need to replace the whole meter. If you want, tell me. Do you have heat shrink? Solid wire on hand? Banana plugs available? I'll tell you the exact quickest F.
Live your life that the fear of death can never enter your heart. Trouble no one about his religion. Respect others.
USS Longship rode the stars with Kirk the Red and battle scars, and Spock, the calm unshaken guide, declared this course is ill-advised. Heave-ho! Let the warp winds blow, to boldly conquer new lands we go. Raise your shields and drink your mead, the Longship flies at Viking speed. Them bones cried out, I'm not a Dane, I'm a Dr. Kirk, this is insane. But Uhura, fierce with braided hair, sang war songs through the frozen air. Heave-ho! Let the warp winds blow, to boldly conquer new lands we go. Raise your shields and drink your runs hot. He drunk the mead, perhaps a lot. While Sulu grinned with silent cheer, and Chekhov claimed we raid for Russia. Yes! Very clear. Heave ho! Let the war winds